Okay, today we are going to look at independent and dependent events. And it says here on page 775 that when one event does not affect the outcome of the other event, the events are independent events. For example, if you toss a coin twice, the first toss has no effect on the second toss. Complete the graphic organizer below. Independent events. Picture it. What do we see here in the picture? That is their example of an independent event. Well, I can say that is spinning a spinner and rolling a number cube. So when I describe it, I can say the letter I spin does not affect the roll. So, spinning a spinner and rolling a number cube are independent events because one does not affect the other. Probability of independent events. The probability of two independent events can be found by multiplying the probability of the first event by the probability of the second event. So we could say the probability of A and B equals the probability of A times the probability of B. You can use organized list, tables, tree diagrams, or multiplication to find the probability of compound events. And we've already done this. If you look at this example number 1 on 776, one letter tile is selected and the spinner is spun. What is the probability that both will have a vowel? Well, there's 4 different choices of letters here, so we could list those letters down the left-hand side here, and then branch off of each one to bring in what you could spin, either an A, a B, or a C. And that will give us our sample space over here on the right-hand side. You can see that there are 12 things in the sample space. Out of those 12 things in the sample space, how many of them are both vowels? Well, E, comma A is both vowels, and A, comma A are both vowels. But all the other ones have at least one consonant in them. So we could say 2 out of the 12 are vowel-only outcomes, which reduces to 1/6. So the probability of getting 2 vowels is 1 out of 6. But we would have to make a tree diagram to get that answer that way. So we know that we could also use multiplication using the fundamental counting principle, the FCP, to find our probabilities as well. We can ask ourselves, what is the probability of 2 vowels? And we could say, okay, what is the probability of getting a vowel when I pick a tile? Well, 2 of the tiles have vowels, and there are 4 tiles. So 2 out of 4 possibility of getting a vowel from the tiles. When we look at the spinner, only 1 of those is a vowel out of the 3 spaces on the spinner. So there is a 1 in 3 chance of spinning a vowel. If I take those 2 things and I multiply them times each other, then I can get my entire probability of getting 2 vowels. First, I'm going to simplify 2/4 down to 1/2. And then 1/2 times 1/3 is equal to 1/6. And so I get the same answer using multiplication, and I don't have to write out the tree diagram. in the sample space. Take a look at example 2. The spinner and the number cube shown are used in a game. What is the probability of a player not spinning blue and then rolling a 3 or 4? So we want to find the probability of not blue then 3 or 4. Well, first let's find the probability of not spinning blue. If you go over here, it's got 5 spaces on our spinner. Of those 5 spaces on that spinner, 1 of them is blue. So there is a 1 in 5 chance of spinning blue, so the chances of not spinning blue are 4 out of 5. What is the chances of rolling a 3 or 4? Well, there are 6 spaces on the dice, on the number cube, and 1 of them is a 3, 1 of them is a 4. So 2 out of the 6 spaces on the number cube are either a 3 or a 4. So I can multiply those times each other. I can simplify 2/6 down to 1/3 before I multiply. Is there anything else I can reduce? No. So I'm going to multiply straight across the top, and I get 4 straight across the bottom, and I get 15. So there is a 4 out of 15 chance of not getting blue and then rolling a 3 or 4. That brings you up to letter problem A, which you can do on your own after the video.